Hi everyone. Today we are going to explore entropy, the idea that system can store disorder using a simple experiment, watching an ice cube melt. So entropy in a thermodynamics is a measure of disorder or randomness. The second law of thermodynamics tells us that in a closed system, entropy tends to increase over time. We are going to demonstrate that this principle with the melting ice cubes. The most fundamental entropy equation derived from the second law of thermodynamics is delta S equals Q over T, where delta S is the change in entropy of the system, Q is the heat transfer, and the T is the absolute temperature. That applies to reversible processes at constant temperature. For more general cases, especially when temperature changes, calculus is needed, where the integral is taken over the process path. So for this experiment, we're gonna need two clear glass or bowl and two ice cubes right here, and we will need our room temperature water for the comparison between just melting of ice and melting of ice with the room temperature water. So here we're gonna take 1 cube each and slide it in here. So here we can see each cube so we're gonna place the ice in the glass as it's shown. Over time, the structure lattice of solid water cubes or ice observes the heat from the surrounding and become liquid water, which has more molecular freedom because of the deformation of the cube. So this is what enthalpy means. When enthalpy increases, the cube will melt because of the heat transfer. And if you add water to one of the and let's add the water, the added room temperature water speeds up the process, more heat transfer happens, and faster enthalpy increases. And we will wait for a few minutes for actually to see the difference between the both experiment, where on the one glass we only have the ice cubes, which will take longer time to do heat transfer, which means it will take longer time to increase the enthalpy. Where over here we took a ice cube and added the room temperature water to it, so the water observes the heat, observes the temperature or the heat transfer happen, and the water becomes more cooler, and the ice cubes enthalpy increases instantly. So this experiment can take 15 to 20 minutes if we want to do calculation and everything. But as you can see now here on the right side, the cube is slowly degenerating, the cube is deforming, which indicates the enthalpy of the ice has gone higher compared to the one just sitting at the room temperature. And what we see in a real world example of entropy in action, spontaneous heat flow causes an invisible change in state from solid to liquid. This demonstrates the second law, entropy increase as energy become more dispersed. And that's what entropy means. change. And here we can see now more. This ice cube on the right side is degenerating more at the faster pace than the one just sitting at the room temperature. So thank you for watching. Now you can try it at home, and you can calculate the entropy by using the equation delta S over Q over T, and where Q melt is m times LF, where m is mass of the ice and LF means latent heat of fusion for ice, which you can find online, which is roughly 334,000 joules per kilogram. And the T melt will be the constant here for the room temperature, which will be 273.15 K. So for this experiment, we use, for example, if we have used 10 kilograms of ice cube, we will have the ice entropy of ice will increase by 12.23 joules per K. Thank you for watching this experiment with me, and you can do it at home and try to calculate the phase changes and the increase in entropy of each experiment, the one with the water and one without the water, just at the room temperature, and measure the time it takes to deform and transfer from solid to liquid. And the observation question, what occurs to the ice cube as time passes? I mean, naturally the ice will melt, and if we add room temperature water to it, it will melt faster. Is it possible to reverse the melting process without applying extra energy? No. What change in temperature occur in the water as the ice melts? Temperature will decrease of the water. And in what way does this experiment connect to the concept of entropy increasing over time? As we mentioned, entropy is where we measure of disorder or randomness in the process. So thank you for watching, and good luck doing this at the home.